Equations of motion. In this video, we'll be looking at the relationship between various components of motion, including velocity, distance, and acceleration, using these equations to determine the motion of an object, and analyzing multi-image diagrams. So let's just start with a definition for projectile. A projectile is an object that has free motion, meaning it's not really tethered to anything, doesn't have its own force like a thruster. And the one we traditionally talk about in the physics course is an object that is launched into the air close to the surface of the Earth. Newton's first law states that an object in motion will remain in motion unless there's a force acting on it. The force when we're talking about projectile motion is gravity. And gravity on Earth, we will use a value of 9.8 meters per second squared as the acceleration. A projectile near the surface of the Earth will have a parabolic path, so a curved path, and you can see this in the diagram on this page. A projectile's motion is the same on the way up as it is the way down, and we consider this symmetrical. Now this of course is in the absence of air resistance, and for all our equations we'll be assuming that there is no air resistance that's affecting the projectile. Alright, so we're going to have a look at the motocross rider in terms of being a projectile. Although the motorbike has an engine, while the motorbike is in the air, the wheels aren't touching the ground and it doesn't have a thrust. So as soon as it leaves the ramp, the motorbike is a projectile. What we have here is a multi-image diagram where photos are taken in consistent time intervals over the course of the jump, indicating the motorbike's position at various time intervals. Now in that absence of gravity, this motorbike will keep traveling in a straight line as soon as it leaves the ramp, but due to the force of gravity, the motorbike travels in this parabolic arc, and once it leaves the ramp and goes up, it comes back down. So at regular time intervals, we can draw vertical lines indicating the horizontal position of the motorbike during these intervals. And what we can see is the spacing of these vertical lines is consistent, meaning the bike travels the same distance at each interval, which indicates that the velocity does not change. Now the speed doesn't change because there's no forces acting on the motorbike in the horizontal direction. Now we're assuming there's no air resistance. The only force on the bike is due to gravity, and that acts in a vertical direction. One thing that you could note is acceleration is 0 in the horizontal direction for these problems, as there's no forces in that direction. Now if we have a look at the motocross strata again, but this time we're considering the vertical motion of the rider, if we draw horizontal lines indicating the position of the rider at different time intervals, we can see that these lines indicate the distance changes with these time intervals. This suggests on the way up that the vertical velocity of the rider is decreasing. On the way down, the spacing of the rider is increasing, meaning it's getting faster, which makes sense. This means that the vertical velocity of the rider is changing, therefore accelerating. After the rider is going up, but before the rider is going down, the rider is not doing either. So the vertical velocity at that particular point, at the peak of this jump, is 0. So that's another important note that you can put down for your calculations. This is another multi-image diagram of a random projectile, with a projectile path being this curved line. The projectile is broken up into its components of vertical and horizontal, and you can see its position at those different time intervals. From this diagram, it can be easily seen that the horizontal velocity remains constant and the vertical velocity changes. The three main equations that we'll use in this topic are shown on this screen. Each equation provides a relationship between various components of motion. With a bit of practice, you'll know which one to use. But with the information that you have for the questions, there will be always one variable that you don't know, and the rest you will know, and it's easy to find which equation to use. So in these equations, the variables v is the velocity, 0 is, or O can be the origin or original or initial velocity. A is the acceleration, and in the vertical direction it will be gravity, and in the horizontal direction it will be 0, and T is time. S is the displacement of the object, which is measured in meters. When analysing these problems, it is very important that we choose either the horizontal or the vertical component to analyse. That makes the questions a lot easier. So when you're looking at time of flight, it'll be vertical component. When you're looking at range, the horizontal component. The following techniques can be used to solve questions. Break the problem down into one-dimensional scenarios and treat the two scenarios of vertical and horizontal independently of each other. When performing calculations, there will be a 0 in your equation a lot of the time. When looking at horizontal motion, the 0 is the acceleration. When looking at vertical motion, the 0 might be the final velocity at the peak of the jump. Because remember, at that point, it's not moving up and it's not moving down, so the velocity is 0. So this question is the same as the one we did previously. Now I'm asking you to find both the vertical and horizontal components, determine the time of flight from that, which is using the vertical component, and then find the range of the projectile, which is using the horizontal component.